All right, so the next one says I want to find a polynomial with the least degree possible that goes through those 3 points. Okay, so let's see if I can. I'm just going to plot the points so that we can kind of see what we're talking about. So -5, 0, that's here. 2, 0, so here. And 0, -1. So it goes through those 3 points, okay? So what I can do is I can say, I can do a quadratic that goes through those 3 points is probably what I'm going to do here. So if it has the zeros, -5 and 2, I know it can be of this form. F of x is equal to ax plus 5, x minus 2. Okay, and then I want it to be the case that when x is 0, this is equal to -1. So I'll plug in -1 here, and then I can plug in 0 here. Okay, and so I'm just plugging in this point here into my function. And so if I do that, I'll get -1 is equal to, and I multiply those together, I get a times -10. So I can divide that -10 over, and I get a is equal to 1/10. So my function f of x is equal to 1/10 x plus 5, x minus 2. And that is my answer to 14. Next one, find each of the following for the given rational functions. Okay, so I need to find intercepts, horizontal and vertical asymptotes, and holes, and domain. Okay, so let's do this one first, f of x. So f of x is that. Let's see if it factors. So at the top, I can pull a 2 out of everything. And then I'll have x squared minus 2. And on the bottom, I have x squared minus 1, which can factor to x plus 1, x minus 1. And in fact, this one, I can pull out the 2, and then I can factor this guy here. It's a difference of squares as x plus root 2, x minus root 2. Okay, and so if, say, I have the same factor that occurs on top and bottom, then I know I'll have a hole in the graph at that point, but I don't have any of the same factors on top and bottom. So what that means is that I'll have asymptotes at these 2 values. So I'll have an asymptote, so I'll have a vertical asymptote at x equals -1 and 1. Okay, and then for intercepts, let's do x-intercept. So to find an x-intercept, I'm going to set f of x equal to 0 and solve for x. So if I set f of x equal to 0, I get 0 equals 2 over x squared minus 2 over x plus 1, x minus 1. I can multiply both sides by x plus 1, x minus 1, and when I do that, if I multiply x plus 1 times x minus 1 by 0, that just gives me 0. And then I can divide both sides by 2, so I just, again, have 0. And then I could subtract, oh, it's minus. Oh, shoot, why did I change the sign here? Hang on, let me change that back to a minus. Somehow it switched over to a plus when I was writing it. Okay, so we got a minus here and a minus there. Okay, so I can add that 2 over, I square root both sides. I get x is equal to plus or minus square root of 2, which I can see are the zeros of the top part of my function. And so those are my x-intercepts. And to find the y-intercept, set x equal to 0. And so if I do that, I get y equals 2 times 0 squared minus 2 over 0 plus 1, 0 minus 1. So that gives me negative 2 times 2, which is negative 4. And on bottom I'll have 1 times negative 1, which is negative 1. So this is a positive 4. So the intercepts are root 2, 0, negative root 2, 0, and 0, 4 are the points on the graph. Okay, and then horizontal and vertical asymptotes. So horizontal asymptote, or vertical asymptote at x equal negative 1 and 1, and horizontal asymptote. So for the horizontal asymptote, we're going to look at the degrees at the top and bottom. They're both squared, and so I look at the coefficients of that. So it's 2 over 1. So the horizontal asymptote is at y equals 2 over 1, which is just 2. Okay. And then determine whether there are any holes in the graph, and the answer to that is no, because I don't have any of the same factors on the top and bottom. And then the domain is going to be everywhere that it's defined. So it's going to be defined for everywhere except where the bottom is 0. So we're basically just taking everything and we're going to throw out negative 1 and 1. So the intervals will be this interval, and this interval. So we've got negative infinity to 0, negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. And if I were to plot this function, I can see that at negative 1 and 1, and then it's a 2, so I can plot all these asymptotes. And then it's going to be doing some things around those asymptotes. So when we plug in, so it's going to be probably doing something like this, or maybe it'll be doing something like, I'll draw it in a different color, it might be doing something like this, right? Anyhow, so it's going to be kind of dancing around those asymptotes in some way. All right, so the other one, I'll do it over here. First thing we want to do is factor it and see what it looks like. So I get 2x minus 1 on top, on bottom, 2x, x, 6, 1, minus 1 plus 6. Let's see. That gives me 2x squared plus 12x minus x. That gives me plus 11x. And then minus 6. So yes, that works out. Now note, one thing we can note here is that I have the same factor in the top and bottom. And so we're going to have a hole when 2x minus 1 is equal to 0. So that's when, if I add that over and divide, that's when x equals 1/2. Okay. And so, so that's the answer there to C when x equals 1/2. And the y coordinate of that will be 1 over 1/2 plus 6. If I look at the rest of this function, it's 1 over x plus 6. So so that's what, how many halves? 12, 13 halves, so it's 2/13 is what that is. So the coordinates of that point are 1/2 and 2/13. Okay, then we want to find intercepts. So again, to find the x-intercepts, we're going to set the function equal to 0. And so let's go ahead and do that. So to find x-intercept, set f of x equal to 0. And so that's going to be 2x minus 1 equals 0 over 2x squared plus 11x minus 6. So when I but I mean, we have to remember that this thing factors on top and bottom. So what does this mean? This is 2x minus 1 over 2x minus 1 x plus 6. And I know that this part is always equal to 1. So for this to be equal to 0, I would have to have 1 over x plus 6 equal to 0. But this thing, this 1 over x plus 6, there's no value of x that can make that equal to 0. So there is no x-intercept. And that makes sense if I think about the asymptotes, because when I look at the asymptotes, I can see the highest power of x is a 1 over, is a x the first over x squared. So since the power on bottom is bigger, that means that the horizontal asymptote is y equals 0. And the vertical asymptote is whatever's left over on the bottom, which is here, which is x equal negative 6. Okay, and so if I'm keeping track of all of this, I've got a graph here, and at negative 6 I have a horizontal asymptote, and then I have, a vertical asymptote, and then I have this horizontal asymptote here at 0, and then my y-intercept is 1, 6, which is here, if this is 1, and then if this is 1, then I have a hole here at 1/2, 12, 2/13, so make a hole here, and so then it's going something like this, right? The graph is looking like that. And then we need to do the domain in interval notation. So the places where I have domain issues is at x equal 1/2 and at x equal negative 6. So I always think it helps to draw out the number line. And so at negative 6 and at 1/2 are where we have issues. So it's everything except for those points. So it's going to break up into 3 intervals. So I have negative infinity to negative 6, union negative 6 to 1/2, union 1/2 to infinity. And so that's what we have there. Next one, I want to evaluate the limit. So this is, again, limit as x goes to infinity of that thing. So for this, I'm going to look at the highest power of x on top and bottom. I see that they're equal, so I look at the coefficients. So this is 3/2. For this one, as x goes to negative infinity, well, this thing is getting bigger and bigger and is going to be, is getting smaller and smaller. It's going to approach 0. Well, okay, so let me rewrite this. So I could do this as limit as x goes to negative infinity of 8 over x cubed plus 5 over x to the minus 1, or x to the first, plus 1. So this term here, as x gets bigger and bigger, it's going to approach 0. Now it's approaching 0 from beneath, because if x is approaching negative infinity, then this x cubed is negative, but this is approaching 0. This, again, as x gets bigger and bigger, is going to approach 0. And then this is 1. So the whole thing is approaching 0 plus 1, 0 plus 1, which is 0 plus 0 plus 1, which is 1. All right. For this one, it's telling me the intercepts here. F of 0 is negative 2. That's this point here. And f of negative 4 is 0. That's this point here. Okay. All right. So what I'm looking at is it's going to have the same... Since it has this horizontal asymptote at 2, that means it's same degree on top and bottom. Okay, and then it has 1 horizontal asymptote, so that means it's going to have a factor of x minus 4 in the denominator. Okay, so let's see here. So if I did like x minus 4 and then like maybe an x, I need the coefficients of those leading terms to be 2 over 1. So 2 over that. Okay. And so if I plug in 0, I need to get -2. So this isn't quite right. So I want to add something, maybe like if I do like a plus b here, maybe, then I'll still have all the things that I need. So let's see if I could do that. So I need, if I plug in 0, say, I want it to be -2. So if I plug in 0, so I need -2 to equal 2 times 0. Oh, shoot. So in other words, if I plug in 0, I need to get -2. Okay, so I could do -2 equals 2 times 0 plus b over 0 minus 4. Okay, so I think that's going to get me somewhere. So I get -2 is equal to b over -4. So I can multiply that, and I get b equals 8. Okay, so that'll work. And so I think, let's see. So I think the function that I'm coming up with is going to be 2x plus 8 over x minus 4. Let's see if that works. So if I plug in -4 there, does that give me what I want? So if I do 2 times -4 plus 8, yeah, that gives me 0. Okay, so that's what I want. So this is the function, f of x equals that. So it's going to have that horizontal asymptote at 4, because of this bottom term. It's going to have a vertical asymptote at 2, and then adding that plus 8 on top made it have the right y-intercept. Okay, next one. The numerator and denominator share at least one common 0. Does the graph have a vertical asymptote or hole at the common zeros? Okay, so if there's a common 0 on bottom and top, it's going to have a hole. But I guess we can talk about that one in particular. So if we have f of x equals x, what is it? It's going to be x plus 2, x plus 2. And on bottom we have x plus 2, x plus 1. So I can see that the common factor is this x plus 2 over x plus 2. And so we're going to have a hole at x equals -2 for that function. Then it says, find a possible formula for a rational function described below. Okay, so it has 2 vertical asymptotes, one at -2 and one at 3. So let's start by working on that one. So that means that we'll have these factors in the denominator that correspond to those vertical asymptotes. Okay, so in the denominator we'll have x plus 2 and x minus 3. Okay, then it has a horizontal asymptote at y equals 0. So what does that mean? That means the degree of the bottom is greater. Okay, and so this is maybe some linear thing on top, ax plus b, something like that. And then I know, so I have a linear thing over a quadratic thing, so that'll have a horizontal asymptote of 0. Then it says it crosses the x-axis once at x equal 5. So that means that when x equals 5, y equals 0. So if I plug in 5 for x, I get 0. So maybe if I let, I can maybe erase this a. Whoops, that was a really big eraser. then I could just let, if I plug in 0 for x, I get, I'm going to plug in 5 for x. So I get 0 is equal to 5 plus b. And so b could be -5. So that's a possibility there. So I could do x minus 5 over x plus 2x minus 3. So that is a possible function for g of x. And that has all the properties I need. Now, I was saying before that it could be like an ax plus b. So as long as, if I could choose a different value of a, I just chose a equal 1. And so, but anyway, it'll be something like that.